we deposit $75,000 and when the interest is compounded continuously. This is the amount. Good. Now we have to talk about doubling time. So if the principal is $75,000, what will be double that amount? Can anyone tell us, if we have $75,000 to deposit, what would be the double amount?
150.
Yes, 150,000.
Okay.
Perfect. So now the question here is find T. That's the question. They told us that all these investments are happening whether on the term of 3 years. No. Now we disregard that because that's not what we are asked to find. They're asking us to find what will be the time that 75,000 will turn into 150,000. So remember how we set it up. How do we set this up? The interest rate is the same, so that is not changed. So this is 0.045. So now the question is, are we looking at this continuous situation? Because they're not telling us that the interest is compounded n times per year. They're not. They haven't told us that. So let's read it again just to make sure. If they don't say, then we have to think in terms of, where's my book? Okay, so then find the doubling time for the given interest rate. So they're not telling us to use annually, compounded interest, monthly, daily. So they're not saying that. So I am going to assume that they are asking the question, since they didn't specify, they're asking the question for continuously. Good. Okay then. So knowing that the relationship, let me write it again. It's here, P e to RT. What is, so this is what we're discussing. So what is A in this scenario? What should I replace A by?
150,000.
Of course, that's the accumulated value. Excellent. The principal is very clear, 75,000. E is very clear. R is very clear. What we don't know is this. Good. Now, what type of equation is this? We're going to review the process of solving it, and we're going to solve it together. What type of equation is it? We know many types of equations. We know quadratic, we know linear, we know radical, we know even more than quadratic, general polynomial, we know absolute value.
Exponential.
What type is this one? I know you said something, but I didn't hear. Forgive me.
Is it exponential?
Of course. That's what we are discussing. Excellent. It's an exponential equation, so we are adding this to the list. Awesome. Good. Now we have to think in terms of how to solve this. And we have to simplify it first. What will you simplify both sides by?
75.
Exactly. 2 equals e to 0.045t. Yes, we have to divide both sides by 75,000. Awesome. Now, anyone remembers how to proceed in this situation? How do we solve for t? Allow me to refresh your memory on this one. The exponential function and logarithmic function are inverses of each other. They are inverses of each other. So we have to apply to both sides the logarithmic function that is the inverse of e. Let's go back to the calculator for a moment. Here it is. See on the calculator, we have this key with e to the x. We have this key with 10 to the x. We have to activate them with a second key. But the plain one corresponding to 10 to the x is log. The plain one that does not need the second key to be activated with says ln. Well, there is a reason why these two are paired on the same key, because they are the inverses of each other. So my mouse just stopped working. Very nice. That's awesome. Brilliant. Okay, I think it's coming back. Okay, good. Maybe. So the two keys, so this key, 10 to the x, and this one, log, they are on the same spot because they are inverses of each other. The same thing here, e to the x and natural log. So please keep in mind that when you see e to the x in an equation, please apply natural log to both sides. So let me turn this off. Okay, I took it out. So that's why they are paired. 10 to the x and log are inverses of each other. E to the x and ln are inverses of each other. Inverses of each other. Very good. Okay, so then coming back, I will apply ln. It's German. It should have been NL if you want. Natural log. Yes, my camera. My electronics are failing on me right now all of a sudden. Okay, so it's German. So it should have been natural log, but it's log natural because, as I said, it's German. And we have to apply natural log to both sides. Now, how do I continue? Well, I have to remember a property of the natural log. So let's list the properties of natural log before we continue. I know I saw that. I haven't even moved. I barely breathed. I'm not sure what's happening. Okay. So, properties. I didn't do anything. I barely touched anything. Let me remove this from here. What else? I didn't do anything. My other camera. And I'm not even touching the table that I have all these on. Okay. So all my electronics are on that table, and I'm here on this table, at this table, so no reason whatsoever. I'm plugging in a different port. Let's see what happens now. Okay, wake up. Is it awake? My camera is out to get me.